We can increase our students' performance and interest in STEM disciplines by using video game development as a mechanism to expand their skills in a manner that is relevant to their daily lives. Many studies show that a large percentage of students use video games every single day. Over the next few minutes, we're going to discuss approaches for utilizing video game development in the classroom. 2, we're also going to look at methods for applying the video game development process in a learning environment. That is, how to develop learning objectives in a way that we can actually use in the classroom. 3, we're also going to look at how to write gaming activities that adhere to state-mandated standards. 4, we're going to also look at how to assess the effectiveness of those learning activities within specific
Historically, there have been 3 methods for integrating video game activities within the classroom. The first method involves using learning sandboxes such as Alice or Game Salad to essentially put students in a isolated environment where they can experience logic and mathematical processing. The advantage of this is that the students often succeed at doing something. The disadvantage is that the types of games that they create don't typically look like the games they usually play. The second method involves using video game development tools, but for teaching another discipline. For example, using SideFX Houdini or using Unity 3D to teach physics makes a whole lot of sense because both of those packages have built-in physics engines. So students can go through and they can take formulas that they learn out of their physics books, put them into a gaming engine, and they can immediately see something occurring within the screen. So it kind of validates whatever they're doing. The third approach involves creating entertainment quality games. The advantage here is that the games that the students create look very similar to what they're used to playing if done correctly. Now, to do this, you have to take into account 2 things. First, it's very important that you temper the students' expectations. Many of the students will want to create the types of games that they go out and purchase, and that's not realistic. Those games take millions of dollars to produce, and they have huge teams. So if you can somehow dial those expectations to actually being what the students are actually going to be able to do, it actually works relatively well. The second thing is that the teacher needs to have an understanding of the game development process. You need to know what a game designer does, what the programmer does, etc., 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 so that then you can design gaming activities around those things. The good news is that within the next few lectures, we're going to look at how to use the game development process within the classroom. So let's go ahead and move on to that next. To adequately develop learning activities around the video game development process, we need to understand how video games are put together and the types of activities that we can attach to that process. Video games are developed by 4 different types of people. First, you have programmers, and that's what most of us think of, right? These are the guys that are responsible for creating the code that's going to run the game. The skills that you would find from these guys would be logic, mathematics, physics, right? So if you have any students that have those types of skills, that's what you're looking at. The second group are artists. This group is responsible for creating all of the visual aspects of the game. The characters, the background, the user interface, anything that has to do with the visual look of the game is going to be created by this team. In a typical video game development team, they are the largest team. So if you have 100 people working, about 70 of them are going to be artists. The third group are game designers. These are the guys that think up of the rules that run the game. They come up with puzzles, ways to entertain people, ways to keep people engaged. So here the idea is not to create the art or even the programming that makes the game go. Instead is to think of ways that you want to keep your audience interested in the actual game. Finally, we have technical directors. In a nutshell, these are people who have some skills in both programming as well as in art creation. And because of this unique mixture, they're able to essentially work as intermediaries between those 2 groups, and they're also able to write custom tools to make the game development process more efficient. Within the K-12 sector, we can tap into any part of this game development process to create learning activities. The most obvious places is using something like a math class or a physics class to have the students write code or come up with the mathematics that run a game. Less obvious places are places such as in an art class. You can have students create 3D models, textures, user interfaces, right? Or even in an English class, right? I mean, if game designers have to go out and create game design documents that detail how a game is going to work, Well, that's done by writing. So instead of the students writing some other arbitrary thing, the students could use those skills to write a game design document that then is executed on by a team to create a game. So as you can see, there's many places where we can use the game development process within the K-12 sector. As educators, we must adequately deliver the standards mandated by our state. Whether we use Common Core standards or state-specific standards, we can't go off into the big blue yonder and spend a significant amount of time on a good learning activity if it doesn't contribute to the standards that we need to cover. So the question becomes two-pronged. One is, how do we match the gaming activity to the state standards? And two, how do we produce something that the students will find worthwhile within the amount of time that we have available? The first question is easy to answer if you have a background in instructional design. First, we'll look at the objectives mandated by the standards. Then we create assessments to test those objectives. And then we match that to the learning activity. To make the gaming activity, we need to provide the students with a pre-made pie that is missing only the slice that matches the learning objectives that we need to cover. In some classes, the missing pie can be significant. For example, in a physics class, it would be possible to spend a lot of time to create a physics-accurate game such as Angry Birds. In other classes, the missing portion could be very little. For example, creating a game design document within the context of an English class. Another approach is to bunch multiple learning objectives into a single activity. Now, this only works if the individual objectives can be properly isolated for evaluation. One example would be to have the students create a game design document that focuses the students to use specific usage and grammar constructs. The users are evaluated on their mastery of the objectives and not the completion of the game development process. That is, we would look at the game design document and we would grade it for how well, English usage is done and how well the grammar is done. However, the activity as a whole would be packaged as a gaming activity because they would be working on creating a game design document. To assess the effectiveness of gaming activities within STEM, it is important to evaluate the activity against the individual learning objectives and not the ability of the student to create a working game. If the point is to teach arrays and recursion, these objectives can be evaluated by looking at the code that the students generate. However, if we are evaluating our students' ability to solve simultaneous equations, we must isolate only this skill within a larger development effort. Let's now change gears and look at some of the tools that are available for us to use as educators in designing some gaming activities.